Okay. We are finishing up this unit today. This is the last lesson that we are going to look at dealing with linear functions. On Monday, we will review. Next Wednesday, you guys will test. Now, next Wednesday is the half-day e-learning. I don't know if you've seen the schedule for that. I can show it to you real quick.
Wait, we have a half day. It's Tuesday.
What?
Tuesday or Thursday.
Wait. Oh, never mind. Nope, too bad. Okay, sorry. Friday, thank you. Oh, wow. Okay, Friday we will review. Next Tuesday you will test. Forget about the e-learning, doesn't affect you. Never mind. All right. So, with that being said, all right. Let's look at taking a linear function and trying to fit it to a set of data is what we're looking at today. So here's the why. In general, data obtained from real-life events don't fit perfect linear functions, but we might still use a linear function to help us analyze this data. Okay, so what we call linear regression is the method that we use to get a linear function to fit a set of data, okay? So let's just kind of look at an example here. It says the data point from a motor oil producing company is listed in the table below. The company wants to study the correlation between the number of minutes of TV ads per day for their product and the total number of oil cases sold per month. What kind of correlation would you expect there to be between the number of minutes of TV ads and the number of cases they sell? What would you expect the correlation to be? What? Right, a positive correlation. The more minutes of TV ads they have, probably the more they sell. If some company has 0 TV ads, and you go to the store and you see all of those choices, you're probably not going to pick the one you have never heard of, right? You're going to pick the one that you've seen all the ads for, right? Does that make sense? Okay. So what you see in the chart, the variable X is the TV ads minutes per day, so you can see 1, 2, 3, and so on. And then our variable Y is units sold in millions. So if there is 1 minute of TV ad per day, they're going to sell 1 million cases. If there's 2 minutes of TV ads per day, they'll sell 2.5 million cases, and so on. What you have below then is a scatter plot of the data in that table. Okay. Question, what does this data look like? What? It looks like a straight line, right. It looks linear. I can tell you that it's not exactly linear, but it looks pretty darn close to a straight line. We can draw what we call the regression line. That is the optimum linear function that describes the data. What that means is it's the best linear function to fit those points, okay? The method that is most used to find this line is called the least squares method. If you end up taking a stats class, you'll probably do that by hand. I remember doing that in a college stats class by hand. It's just a lot of tedious calculations. But we have these beautiful things that will do it for us. Okay. Basically what the least squared squares method does is it calculates the minimum sum of squares of the vertical distances. This is not going to make any sense to you, but just in case you're curious. Vertical distances between the points and the line. Don't worry so much. I just thought maybe you'd be curious what that method was, but I'm sure you're all saying I don't care. All right. So if you look at the next picture, it says the line pictured below is the best fit line, just another word for regression line for this example. So you can see that it is a straight line, but notice that you have a few points that are above your line. You have a few points that are below your line. Basically, your best fit line will kind of have an even number of points above your line and below your line, okay? It's not going to go through all of those points. It might go through a few, but it's just kind of minimizing the space between the points and the line, okay? All right, before we actually get into calculating one of those equations, we need to talk about correlation for just a moment. What we call the correlation coefficient, this is represented by the variable r. This describes how well a regression line fits the data. The correlation coefficient describes how well your line fits the data. So if you go back to this example, that line fits that data pretty darn well. I mean, it's almost touching every single one of those points, okay? We'll see some examples where it might not be quite as good, but your correlation coefficient is going to be a number between -1 and +1. If your correlation coefficient is equal to 1, that means the data fits the line. With a positive slope, it fits it exactly. That would mean your data does have a linear relationship. Kind of going the other direction, if r equals a -1, then the data fits perfectly for a negative slope. If your correlation coefficient is negative, we are looking at that fitting a line with a negative slope. Kind of already mentioned that. Vice versa, for r being a positive value, this is fitting a line with a positive slope. So your correlation coefficient is going to be somewhere between -1 and +1. If you are right in the middle of that -1 and +1 at 0, this means that your data is totally scattered and there's no relationship, no linear relationship. Okay, so what you have below that is just several different data sets and then the corresponding correlation coefficients. So let's look at these individually. I first want to look at the 3 positive correlations. So again, if it has a correlation coefficient of 1, that means your data is linear. That means you can write a specific linear equation that will fit that set of data. If you look at the next one, we're going to say that this correlation coefficient is about 0.8. It's still looking, I mean, I can draw a best fit line through there that's going to fit pretty well. There's a pretty high positive correlation. But as those data points get more scattered, it's going to be harder to find a line that fits that. So as that correlation coefficient gets closer to 0, you're going to have less and less of a relationship. Okay? If you look at your 0, like I said, your data points are just all over. There's no sort of linear trend going on there. Okay? And then going the other direction, again, if you go all the way to -1, this means that there is a specific linear function with a negative slope that will fit those data points. This is a linear relationship. And then going the other direction back down closer to 1, again, as those data points get a little more scattered, your correlation coefficient is going to change based on that. Okay? Any questions so far? All right, now let's actually find it. Okay, the example we have says the following table shows the IQ of 10 students and the number of hours of TV each watches per week. So we have the IQ, the corresponding hours of TV watch. Part A says make a scatter plot of the data using your calculators. Okay, here's where you really want your calculator instructions. I'm going to go through this with you, but you're going to need to know what these directions mean. At this point, I think I'm going to let you use this on your tests. I haven't heard from any other pre-cal teachers that I shouldn't, so there you go. But you have to know what all those instructions mean, okay? So if you look at this first part, take your calculator. We want to make sure that we are starting our calculators with a clear memory. So what we're going to do is hit second. Try to make this as clear as possible. Okay, your second button, and then your plus sign will be memory. Okay, so second plus sign gives you the memory. And then you want option 4, which is to clear all lists. So scroll down to option 4. Like it says, hit enter. And then hit enter again. I don't know how I can get this so you can see it better. So it says clear all lists, hit enter, it'll tell you done. All that's done is cleared all your lists. That is in case you've already done a scatter plot, you already have data in there, you want to clear that out for your next one, okay? All right, the next thing that we need to do is enter our data points. So part 2, to enter points, it says go to stat, it's right underneath delete, hit stat. You get some options here. You want option 1, which is edit. So hit enter, and then you should see 3 empty lists, okay? Like it says on your little cheat sheet here, use L1 for your X values, use L2 for your Y. So this is straight off your note sheet that IQ list is going to be your list for L1. So I'm just going to enter those in. So 110, hit enter in between, it will take you to the next one. So take just a moment to enter all those in. Just be really careful that you're not hitting a button wrong because that will throw off everything. I always like to go back through and double check that I entered all my numbers right. When you're satisfied with your first list, you can scroll over using your arrow key to list 2 and enter all of the TV times. You should have the same number of data points in your 2 lists. All right, so we've got all those entered. Now to actually see our graph. So we're on part 3 to see the graph of the points. It says second y equals. If you look right above your y equals sign, do you see where it says stat plot? Okay, so hit second y equals. That will give you a list of all of your stat plots. We're going to use the first one. You need to hit enter on number 1 because you need to turn that plot on. So hit enter and then hit enter again when your cursor is on the on. That makes sense? And then you can hit graph. That is not what I want. I know. It's because why? Oh, okay, let's do this. Go to Zoom, Go to Zoom, number 9, Zoom stat, and hit enter. Then it should give it to you. It's because our points weren't in our viewing area, our viewing window. You should end up with a graph that looks like this. Are we getting there? Yeah? So after you go second y equals, you turned your first plot on, then go zoom number 9 so that your plot will fit in your viewing window. Okay, so that's part A. Part B says in your notes, use a calculator to find the least squares regression line and the correlation coefficient. Okay, we're going to skip this next section. I want to go right down to where it says to get the equation of the line. To get the equation of the line. You are going to go back to stat. So underneath delete, go back to stat. You need to scroll over so that you are under your calc menu. And you want number 4 where it says linear regression. So scroll down to number 4, hit enter again. You should be getting negative 0.167, etc. for A, and 27.51, etc. for B.
Wait, how did you type that in?
No. Go stat, calc, number 4, enter twice. So take a look at what this is telling you. You have to understand what these values are. Not right now. You have to understand what these values are telling you. Look at what it says. It says y equals ax plus b. So what is that value of A that it's giving you? Your slope, and your value of B is your y-intercept. So if you go to your note sheet then, and it asks you to find the least squares regression line, it's going to be y equals, and we'll go to like 3 decimal places, negative 0.167x plus 27.513. You're taking that slope and y-intercept that it's giving you, you're just putting those into your slope-intercept form for a line.
Wait, do we the building is 514?
Huh?
Because it's 513.
Oh, yeah, thank you. All right. Now what we need to do is find the correlation coefficient. So that's the next part of your instructions to get the factor of regression. That's the same as your correlation coefficient. All right, for this you want to hit your VARS button, which is right above tangent.
Wait, do we hit clear?
It doesn't matter. Hit that VARS button. You want option 5, statistics. It says to scroll over to EQ. And then you should see under number 7, R we know stands for correlation coefficient. So you're going to select that, hit enter again, and it gives you your correlation coefficient. It should be negative 0.5388.
I think if you have the TIA4, like when we
Is that a little different?
it'll like it just all shows up together. Like the first thing we did, the R squared and the R will be like under the like A and B R.
Okay, there you go. Okay, 4C, to graph the least squares regression line, just take that equation that we have, go to your y equals, and type that in. If you hit graph, then it will show not only your data plots, but also then our best fit line. Okay, so the question is, what does the correlation coefficient tell us about this data? How well is this line fitting our data? Not super great. I mean, I would still say that there's a negative correlation. I would say there's a relatively good fit to the negative sloped line. I wouldn't say there's a really good fit, but I would say we do have kind of a negative trend going on there. Okay.